Okay, this is my carry lookahead adder implemented in Minecraft. I'll just quickly go through um, each, just the whole implementation. So first, this is my carry signal. This is my input A0 and B0. Um, this is an XOR gate and an AND gate. I'll just show those working right now. This is the XOR and then the AND gate. Okay. And this is the same across my other um, inputs. Okay, so here I'll go through just my schematic. So, okay, this is my carry propagate, which is the output of my first XOR, and then carry XOR together to create my sum 0, which outputs over there. This is my carry propagate and my carry ANDed together, then my carry generate, which was ANDed previously by my red and blue inputs over there, or together to create my my first carry, which is over there. All right, moving over here. This XOR creates my propagate 1. This AND gate creates my generate 1. Then we have my first triple AND gate, which is the carry signal, the carry bit, the propagate 1 and propagate 0 and propagate 1, and it together. Then over here we have my carry generate 0 and my propagate 1, and it together. Then my generate 1, which was from my red and blue, and it together in the beginning, all ORed together to create my carry 2. Over here we have the second sum 1, which is the XORing of carry 1 and propagate 1. Alright, moving on to the third block segment. This is my propagate 2. This is my generate 2. Just going to follow my propagate 2. Okay. Here we have the I'll show the sum first. The carry 2 XORed together with propagate 2 to create sum 2. Then we'll follow over here to my 4 input AND gate, which is propagate 2, propagate 1, propagate 0, and carry and it together. Then over here we have my generate 0, propagate 1, and propagate 2 and it together. And then we have my follow here. Oop, excuse me. Got a bit lost here for a second. Okay, yes, it was over here. We have my propagate 2 and my generate 1 and it together, which then we can follow over here. Getting lost. Okay. And then my generate 2. This is all ORed together to create carry 3. Alright. It's a little messy in the last two parts, but that's okay. Okay. Now the last segment, we have this is propagate 3. This is generate 3. I'm just going to follow this for clarity. Okay. in my 5 input AND gate, we have, in the first segment, we have my propagate 3 and my propagate 2 and it together. And then over here, we have my carry, propagate 0, and propagate 1 ANDed together, which both of those inputs are then ANDed together to create one of the outputs for the OR later on. Okay. Moving to the 4 input AND gate, which should be okay, right here. This is different from the one over here. There's the other 4 input AND gate. This is a different 4 input AND gate. Okay, this is generate 0, propagate 1, propagate 2, propagate 3. And together to create one of the outputs for the OR. Then we have over here. I'm looking for my 3 input AND gate. Here we go. We have my propagate 3, generate 1, and propagate 2, and it together. And then lastly, we have generate 2 and propagate 3 and it together. Then the output of that one, along with the 5 input AND gate output, and the generate 3 are ORed together. Then over here, the 3 input and the 4 input AND gates are ORed together, which are both ORed together to create one output, which is lastly carry 4. Okay. Now I'll just show an example of the addition. Okay. So I will turn my carry on, and I will do 1 plus, wait, I'm sorry. I will do 2 plus, why don't we do 2 plus 4? Okay, there we go. So carry 3 and sum 3 were turned on, showing the output. Okay, thank you.